This is Mrs. Staub coming to you to talk to you about a few different things. Should be a pretty quick video. If I go too fast, you can always slow it down or repeat it. What we know so far about the atom is that it has a few parts. One, it's got the electron and the proton. What we haven't talked about yet is that the atom also exists inside there as a neutron. Now, neutrons are going to come more into play later on in the semester, but right now we have to know how to count the number of neutrons that we have. So looking at the charges of things, we know the electrons are zipping around on the outside, and they have a -1 charge. They're negative. And the same number of protons exist as electrons. To balance each other out, protons are positively charged. The protons and the neutrons are the things that exist inside of the nucleus. The atom as a whole is going to be neutral in charge because you have the same number of electrons as protons, and the number of neutrons are neutral, so you can have as many or as few of those as you need and it wouldn't change the charge. One thing also to notice on here is the relative size. If you take a look at the proton and the neutron, which both exist inside of the nucleus, they're about the same size. Not exactly, but very close. So if you look at your relative mass, they're like a 1-to-1 sort of ratio. The electron, however, is freakishly small. 10 to the -28 is way different than 10 to the -24, which is what the proton is. Which means, by a ratio, it's 1 to 1800 kind of ratio. So the electron is a lot smaller and lives on the outside. So what I want to talk about today kind of starts me out with cookies. They do kind of look good, don't they? If you ever had Chips Deluxe cookies, you'll notice that they're very systematic about how many M&Ms they have. Every Chips Deluxe cookie, unless it's damaged, happens to have 1, 2, 3 M&Ms in it. They all have 3 M&Ms to every single cookie. They're exactly the same in that way. But if you counted the chocolate chips in every cookie, they would be different. You would still call every single one of these cookies a Chips Deluxe cookie. And you would know it's a Chips Deluxe cookie and not some other brand cookie because it has 3 M&Ms in it every single time. But what it doesn't have the same is the number of chocolate chips. Now what I'm getting at here is we can see that everything is a cookie, but they're just slightly different. But they have some things that are always the same, but some things that are always kind of different. Atoms are the same way. Every single atom of the same element, like let's say you have carbon, all carbon is going to have the same number of protons, but they might have a different number of neutrons. You might have heard this before. This kind of relates to our Chips Deluxe cookies in that they all have the same number of M&Ms, same number of protons, just a different number of chocolate chips, different number of neutrons. But you'd still call them Chips Deluxe cookies. Isotopes. I'm sure you've heard the word before. Isotopes are atoms with the same number of protons, but a different number of neutrons. Taking a look at the picture on the side, you can see that every single one of these pictures has 1 proton. They're the blue dots in the middle. I know it's hydrogen because it has 1 proton. All hydrogens have 1 proton. We also have the same number of electrons as protons, so 1 electron for each of them. But what's different is the number of neutrons. This first one has 0 neutrons. The second one has 1 neutron, and the third one has 2 neutrons. They're still all hydrogen, but they're isotopes of each other. This first atom is an isotope of this atom, which is an isotope of this atom. The word atoms and isotopes are kind of interchangeable. If you need to read about this in your textbook, you can see it's on page 115 to 121. Now what I want to talk about is when you look at your periodic table that I gave you, how do you know how many protons, neutrons, and electrons are inside a specific element, or atom, I should say. On the periodic table, it gives us some great information. I've kind of labeled them for you here. Top one is pretty obvious. The fluorine is the element name. The whole number that's on there on the top part is the atomic number. And that tells us the number of protons, which is also telling us the number of electrons that we have. Protons and electrons are the same because protons are positive and electrons are negative. I use these little symbols because protons is a big word and electrons is a big word. I think it's easier to use symbols. So my P for a proton with a positive because protons are positively charged, and electron with a negative because electrons are negatively charged. Moving down in our periodic table, we have the F, the symbol, and down at the bottom number, your 19 is your atomic mass, or also called your mass number. This is going to be equal to the number of neutrons plus protons. So in this case, for fluorine, I happen to have 9 protons, 9 electrons, and on the bottom here, since this is the number of protons and neutrons, I have to have 10 neutrons. 19 minus the 9 will give me the 10 neutrons. We can also write them without using the periodic table in our isotopic name or the isotopic symbol. Starting with the name, the chem gods say you should always have it lowercased. So fluorine should always be lowercase. The only time it would be uppercase is if it's in the beginning of a sentence. Now, I'm not going to get all crazy if you uppercase it, but just to let you know, that's what the chem gods say. The 19 is our mass number. And from this name, fluorine 19, I can tell all of the parts that I need. Fluorine tells me, I can look on the periodic table, that it's number 9, and that tells me there's 9 protons. And the 19 will tell me how many neutrons I have. Same thing over here for our isotopic symbol. You can see the mass number, the 19 is on top. The atomic number, the 9 is on the bottom. And that makes it really easy because if I wanted to find the number of neutrons, I just take 19 minus 9 to get my 10. 10 neutrons. My 9 is my number of protons. And my top number, being my mass number, is my number of neutrons plus protons. Okay, so taking a look at our periodic table, you can see fluorine's right up here, and that's where I got fluorine with a 9 in the F. So every element, if I pick out a different one, like vanadium, is number 23. That's its number of protons. Now you can see the bottom number is a little bit different. We're going to talk about that in class. But what I like to do, from the information you've got so far, you don't have to go read the textbook or anything, I like you to go to this Google form, it's also posted on my website, and answer the questions to the best of your ability. If you get every single one wrong, that's okay. That just means I really need to come and talk to you about what you learned here. So do the best you can. It's not collected for a grade, it's merely collected saying, yes, you watched the video, and you had no other questions for me. Or if you do, put them in the Google form. Alright, I'll see you tomorrow.